Good evening, guys. Tonight we're going to continue talking about solving inequalities. The goal here is to get us moved up in the next couple of days to solving systems and graphing systems of inequalities. So tonight's objective is 4-7. We'll introduce you to how to graph linear inequalities with two variables. All right. So let's go ahead and get started. We'll begin today with example 1 is a story problem. It says party in Paris. Interesting name, right? It's providing food for a chicken party. I don't know why, but that's apparently what we're doing. Her client only likes chicken nuggets and chicken wings. So we have two different things here. I'm going to highlight here chicken nuggets. Separately, I'm going to highlight chicken wings. She went to the supermarket and she found that chicken nuggets cost $2 a pound, and her chicken wings are going to cost her $4 a pound. Now she wants to spend exactly $12. If that's the case, how many pounds of chicken nuggets and wings could she buy? So she wants to spend exactly $12. How many pounds of chicken nuggets and wings could she buy? We're going to set up an algebraic equation to graph her situation. So we're going to start today by setting up an equation. Now, if we're setting up an equation, we're going to be graphing. Let's go ahead and use variables x and y. Here's what you're writing in your notebook. So x and y. We're going to define these variables really quickly. X, let's just go ahead and use x as the number of her chicken nuggets. So we know the cost, we don't know how many she can buy. So the unknown here is the number, or how many she'll be able to buy. So here's the number of her chicken nuggets. And then y, we'll use the number of wings. Okay, if we're using x and y and we define those, that helps us again just to come back through the story problem and know what our x and our y represent. So we know the cost of all these things. So she's going to be paying $2 a chicken wing, or a pound of chicken wings. So 2x, sorry, those are nuggets, plus 4 pounds for chicken wings. And she wants it to be exactly, notice that's exact is equal to $12. Okay, so we've set up our equations. 2x plus 4y is equal to 12. Now, an interesting thing to notice here is that these are all in terms of dollars. It's $2 for chicken nuggets, $4 for a pound of chicken wings, and that's all $12. So that actually helps me think about how do I set up the equation when I'm thinking about what do I have, what information do I have. It's all in terms of dollars. My unknowns are the number of pounds I can buy. So 1a asks us then, what are the possible combinations of chicken nuggets and wings that she can buy and spend exactly $12. We're going to show that by graphing over here. But in order to graph this, I need to take 2x plus 4y equals 12. And I have to put it in a format. It's really easy for me to graph. So I'm going to solve for y in this case and put it in slope-intercept form. I'm going to start by subtracting 2x from both sides. 4y is equal to negative 2x plus 12. Divide both sides by 4. And I'll be left with, I'm going to actually just bring this down over here to the left so I have space. This is going to be y is equal to negative 1 half x, because this is negative divided by 4, it simplifies to be negative 1 half. Keep the x, and then 12 divided by 4 is just 3. So y is equal to negative 1 half x plus 4. I'm going to go ahead and graph that. So here's my x-axis here. Remember, x was the number of nuggets. I'm going to put nuggets. And here's my y, and this is wings. And here's 0. Let's go ahead and put 1, 2, 3. And I'm going to go down 1, 2 to the right. Down 1, 2 to the right. Down 1, 2 to the right. So this would be, let's go ahead and write a scale on here. I'm just going to go back 2, 4, 6, 8, 10. Here's 2, 4, 6, 8, and 10. So what are the possible combinations of nuggets and wings that she could buy and spend exactly $12? Well, if I look here, these dots are all, or these points are all ordered pairs that are solutions to the equation. So she could buy, and I'm just going to list some ordered pairs here. She could buy 0 pounds of nuggets and buy 3 pounds of wings in ordered pairs 0, 3 and spend exactly $12. Or she could buy 2 pounds of nuggets and 2 pounds of wings and spend exactly $12. Or she could spend 4 pounds of nuggets and get 1 pound of wings. Or she could get 6 pounds of nuggets and no pounds of wings and spend exactly $12. Notice these are all ordered pairs. These are 1, 2, 3, the 4 ordered pairs. And if I think about an ordered pair is just x comma y, this is x, which is the number of nuggets, and y is the number of pounds of wings. Okay, so what if, I'm going to put a line here as best I can. Okay, now what if she wanted to spend less than $12? So the line represents her spending exactly $12. Those 4 ordered pairs, and actually all the ordered pairs, we could buy half pounds, we could do that, but that line represents exactly $12. What if she wants to spend less than $12? What would our equation become? Well, if I think about what this is asking me to do, if I have $2 for every pound of chicken nuggets plus $4 for every pound of chicken wings, and that's equal to $12 here, this again is my total that I can buy. And if I want that to be less than $12, if I want my total to be less than $12, all I have to do is change that equal sign to be an inequality, or a less than sign in this case. So here, in order for us to spend less than $12, we would just change it to be an inequality. It changed from an equation to an inequality. So we've got 2x plus 4y is less than 12. Alright. And what possible combinations are there? Well, if I look here, back up here at the graph, any of these combinations that are below the line would give me a total amount less than $12. So if I just think about what this one would mean right here, it means she's bought 1 pound of chicken nuggets and 1 pound of wings. And so if I substitute in the ordered pair, let's just use the ordered pair 1, 1 here, and we substitute into 2x plus 4y. Wait, no, is that actually less than 12? By substituting in 1 for each one of the variables. We know that 2 plus 4 is 6. And that is less than 12. So anywhere, any of these points under or below the line will give me a total that is less than $12. Now what if, I'm on 1C now, what if Paris wants to spend more than $12? Well, let's think about the equation. She wants to spend more than $12. We just changed for part 1b when she wanted to spend less than $12 to make this a less than sign. So if she wants to spend more than $12, let's just go ahead and say, we think we would change this to say her total, remember this is the total she can buy, is going to be greater than $12. So she wants to spend more than $12, her total should be greater than $12. And our equation then becomes an inequality. This is important. What happens to our equation? It becomes an inequality. And what possible combinations are there? If I look back up here at the graph, if when she wanted to spend less than $12, I was looking at all the points below the line. Now she wants to spend more than $12, I could look at all of the possibilities up here that are, even including this one here, that are above the line. So any of these points up here, any of them, all the way up here, all of them, this one, okay, this one, all of them, are going to give me a total greater than $12. So any of those possible points, any of these above the line are possible. So graphically, how would you describe all of the combinations that cost exactly $12? So here's what we're going to say. The points that are exactly $12 are on the line. So the combinations that are exactly $12 are on the line. Combinations less than $12 are below the line. And combinations more than $12 are above the line. Okay, and we're going to show you probably how that looks graphically. Instead of just circling certain points, we're going to show you how to do that all together. If you need more time, go ahead and pause the video and get this copied down in your notebooks. So if I look at example 2, I see I'm asked to graph the inequality negative x plus 3y is less than 9. Now, never before have I been asked to graph an inequality. So I know that if I were asked to graph an equation, I would want to put this in slope-intercept form. Again, that stays true. So I'm going to, first thing that I want to do is solve for y, put this in slope-intercept form. So here's what I'm going to do first. I'm going to say negative x plus 3y is less than 9. I need to solve for y first. Very important. I'm going to add x to both sides. Now I've got 3y is less than x plus 9. And then I'm going to divide by 3. Now again, whenever I divide across an inequality, I want to make sure, am I dividing by a positive or negative? If I divide by a positive, I just keep the inequality the way it is. But if I were dividing by a negative integer, like a negative 3, I would have to flip the inequality. But here's positive 3, so it's going to stay the same. So this becomes y is less than 1/3 x plus 3. This is the equation, rather the inequality. This is the inequality that I want to be able to graph here. And again, just like with an equation, I'm going to start the y-intercept. So here's 3. Put a dot at 3. And the slope is 1/3. I'm going to go up 1 over 3. Up 1 over 3. Up 1 over 3. And there I go. Now, what changes is I look at the inequality and I need to know, is this going to be a dotted line that I'm graphing, or is this going to be a dotted or solid, or am I going to shade above or below? I know that since y is less than, there's a less than sign here, 1/3 x plus 3, I'm going to need to shade everything below the line. So whenever I see this less than, just like in our notes, it means to shade below. All of the ordered pairs below the line satisfy inequality. So I'm going to shade the closest thing I have to red, which is apparently this pink color. So I'm going to shade everything below the line, meaning all of these points down here, all these ordered pairs, are possible solutions to this inequality, y less than 1/3 x plus 3. Now, do I make it a solid or a dotted line? I think back to when I was graphing on a number line. If I had a less than or greater than, that value was not included in the solution set, so I left an open dot. The same is true when I have two variables, the x and the y. When I don't have an less than or equals to, when I don't have the equals to part of the sign, then whatever is on the line is not included in the solution set. And I signify that by making a dotted line. So I'm going to make this a dotted line because the line itself is not included in the solution set. If it was, the equation would read y is less than or equal to 1/3 x plus 3, and if y was less than or equal to 1/3 x plus 3, I would make it a solid line. In this case, it's not. So I'm shading below the line because it's a less than, and I'm making it a dotted line because it's less than, not less than or equal to. Let's go ahead and go to our last example. So we're going to graph, and we're going to do both of these on the same equation, or on the same plane. So I'm going to graph x is greater than or equal to -4. Looking at the inequality, and I know it's going to be a solid line because of the equals part right here. And I need to make it a solid line where x is equal to -4. So x is equal to -4 means that it has an x-intercept of -4, and all of the x coordinates in the ordered pair is equal to -4. So this is going to turn out to be a vertical line at -4, at x equals -4. And I'm going to graph this. I'm going to move it. Or not move it. I guess I'm going to draw this one by hand. So it's a solid line, vertical line, where x is equal to -4. And I need to know which way do I shade. Am I going to shade to the left or to the right? Since there's no above or below a vertical line, I have to think any x value that's greater than -4 is going to make this true. So is -3 greater than -4? Yeah. Is it -5 greater than -4? No. So I'm going to shade towards that -3, which is here, or towards that 0, which is here. So I'm going to shade to the right. And again, I'm going to pick the closest thing I have to red. So all of this is included in this solution. I'm going to flip to blue here. And then I'm going to graph y is greater than 1. I know it's going to be a dotted line because it's not doesn't have the equals to component in the inequality. So I want any line that is greater than the line y is equal to 1. So here's y is equal to 1. All the y values on this line are equal to 1. So we know y is equal to 1 is a horizontal line. I'm making it a dotted line since there's no equal to component in the inequality. And I want to think about, it's a greater than sign here, which means I'm going to shade above the line. So it includes all of this. And whether you realize or not, what you've done is you've just graphed your first system of inequalities on a coordinate plane. What we'll do is we'll talk over the next couple of days about exactly what that means. But as for now, make sure these are in your notebook, and I'll see you guys tomorrow.